So, class, welcome to the lecture number 8 of the course. Today I am uploading two lectures, that is lecture number 7 and lecture number 8. So, in this lecture, I will discuss about the nodal analysis. The name of the topic is nodal analysis. With voltage source. Okay, nodal analysis with voltage sources. Okay, so here the nodal analysis with voltage source with here we have two cases. Okay, so we know that a voltage source, if you will look at this diagram, a voltage source can be connected, like it can be connected between a non-reference node and a reference node. Okay, so in case the voltage source is connected between non-reference node and reference node, so voltage of the non-reference node is set equal to the voltage of the voltage source. Okay, so I'm saying, since if you will see this 10 volt voltage source, it is connected between non-reference node 1 and reference node. So the voltage of the non-reference node where this voltage source is connected, the voltage of that non-reference node is set equal to the voltage of this voltage source. That means V1 will be equal to 10 volt. Okay, this is the first case. So in the second case, we are seeing when a voltage source is connected between two non-reference nodes. Okay, so when a voltage source is connected between two non-reference nodes, it will create a super node. I'm saying when a voltage source is connected between two non-reference node, it will create a super node. Okay, what is super node? How it is created? If voltage source is connected between two non-reference nodes. Okay, so then a super node is created. And what is a super node? A super node is formed. A super node is formed by enclosing the voltage source, connected between two reference nodes and any element connected in parallel with it. So what will be the whole super node? I'm saying a super node is formed by enclosing the voltage source connected between two non-reference nodes and any element connected in parallel with it. So what is this whole will create a super node? This voltage source is connected between two non-reference nodes, and what is the element that is connected in parallel with this? It is this circuit. Okay, so I am saying a super node. What is the condition for super node? That is, a voltage source should be connected between two non-reference nodes. And I am saying a super node is formed by enclosing a voltage source that is connected between two non-reference nodes. Okay, and any element connected in parallel with it. I am saying a super node is formed by enclosing a voltage source connected between two non-reference nodes and any element connected in parallel with it. Okay, so what is I am saying, what is a super node? Is formed by enclosing a voltage source connected between two non-reference nodes. So it is this, and any element connected in parallel with it. Okay, so this will create a super node. You know that in super node, we are saying that we have a voltage source. Okay, that is connected between two non-reference nodes. So if we cannot apply KCL here. Okay, if you will apply KCL at node number 2, what will that mean? This current plus this current is equal to this current this current plus this current. But do you know what is the current flowing through a voltage source in advance? No, we don't know the current that is flowing in a voltage source in advance. We know the voltage across the voltage source, but we don't know the current that is flowing through the voltage source. Similarly, we know the current through a current source, but we don't know the voltage drop across the current source. ओके, वोल्टेज सोर्स में हमें पता चलता है इसकी वोल्टेज कितनी है, मगर इसमें अंदर कितनी करंट फ्लो होती है वो हमें एडवांस में पता नहीं होता, इसलिए हम इस पर डायरेक्ट KCL नहीं लगा सकते. सो देयर आर सम ना प्रॉपर्टीज ऑफ अ सुपर नोड. सो लेट अस सी व्हाट आर द प्रॉपर्टीज ऑफ अ सुपर नोड एंड देन वी विल सी व्हाट आर द स्टेप्स टू सॉल्व द दिस ना सुपर नोड. सो प्रॉपर्टीज ऑफ अ सुपर नोड. Properties of supernode. So what are the properties of supernode? Number one, so we are saying the voltage source inside the supernode. This hole is a supernode. This hole is a supernode. So I am saying we are saying the voltage source inside the supernode, it provides a constraint equation needed to solve for the node voltages. We are saying voltage source inside the supernode provides a constraint equation needed to solve for the node voltages. Please memorize these properties because I may ask these properties in your exam. Okay? So second is, we are saying a supernode has no voltage of its own because this supernode is formed by this hole. Okay, you cannot say that the voltage of the supernode is equal to the voltage of the voltage source is equal to the voltage of the whole supernode. Okay, so we are saying a supernode does not have its own voltage. Though we have a voltage source inside a supernode, it has its own voltage, but a supernode has no voltage of its own. A supernode has no voltage of its own. And the third is, like when I discussed about the nodal analysis, we were applying KCL. Okay, but we cannot apply KCL here because we don't know the current that is flowing through the voltage source in advance. So we have to apply both KCL and KVL here. So both KCL and KVL are applied on supernode. Okay. So that though we say that the circuits with supernode, circuits with the supernode, they are analyzed using the same 3 steps in the nodal analysis. In the nodal analysis, we were also using the 3 steps now. So the circuits in the supernodes, the circuit with supernodes, they are also analyzed with the same 3 steps. Let me get those pages back so that I can show you. Okay. Yep. Here. This was step number 1. This is step number 2, and this is step number 3 for nodal analysis. Okay. For nodal analysis. So we are saying though circuits with supernode, they are analyzed with the same 3 steps as in the nodal analysis. However, we say that these supernodes, they are treated differently. Why are they treated differently? Because we know that an essential component of nodal analysis is applying KCL. Okay. So in nodal analysis, we were applying KCL, and for applying KCL, we should know the current through each element. Okay, we should know the current through each element, and there is no way we can determine the current through the voltage source in advance. We can determine the current through this resistor, we can determine the current through any resistor, we can determine the current through a current source, but we cannot determine the current through a voltage source in advance. Okay. So that is the problem. That's why we are saying that these supernodes, they are treated differently. Though same 3 steps will be applied, which are applied in nodal analysis, but a slight difference is that no, we have a constraint equation here because we cannot apply KCL directly to this supernode. Okay, because we don't know, for applying KCL you should know what are the currents, but here we don't know the current that is flowing through in the voltage source in advance. Okay, so how do we treat these super nodes then? So let me this is, suppose this is a problem, let me label the direction of currents. I am saying, suppose this is my current I1, so this is current I2. Okay, this is current I3. This is the whole super node. That's why I am not showing any current that is flowing through this. This is the whole super node, means this is an artificial node. No, this complete node is an artificial node. Okay, this is a artificial node. Okay, this is I3, and the current that is flowing here, it is, I suppose here I am showing it is I4. So now apply KCL at node 1. If you will apply KCL at node 1, what will you get? Sorry, apply KCL at super node directly. Apply KCL at super node. You will get, what is the, so this is super node. This is my super node. No, this is my super node. No, I am saying this is my super node. So this is my V1 or V2. This is my V2. This is my V3. So here I have a voltage source plus minus 5 volt. Okay. So here one current is going here. It is I2. One current is coming from here. It is I1. And one current is going down here. It is I3. And one current is coming from here. It is I4. Okay, so if I will apply KCL at this super node, what are the currents that are approaching this node? This is a complete node. I1 is going towards this node, and I4 is going towards this node. So it will I will get I1 plus I4. And what are the currents that are leaving? It is I2 and I3 is equal to I2 plus I3. So I1 is nothing but V1 minus V2 by 2. And what is I4? I4 is nothing but V1 minus V3 by, what is this resistor? V1 minus V3 by 4 equal to, what is I2? I2 is the current that is going down. It is V2 by 8. And what is I3? V3 by 6. V3 by 6. Okay. So got it? So this is my first equation. So this voltage source was how much? Wait a minute, I think let me see if I can solve it. Okay. Okay, so this is my equation first. Okay, this is my equation first. You know what is the value of V1? V1 is equal to 10. So if you will solve this equation, you know V1 is equal to 10. V1 is equal to 10, and you can express equation 1 in terms of V2 and V3. Okay, so V2 and V3, so there will be two unknowns in equation 1. Similarly, what is the second node? We are saying how a super node is formed. KCL. Now we will have to apply KVL as well on this super node. So what is, how super node is created? I will again redraw it. So it was like, the circuit was like this. Okay. Some part I will draw in dotted so that it will not create any confusion. The circuit was like this. Okay. So here the voltage was plus minus V2. Okay, if you will talk here, this is the node. This node is connected between this branch is connected between non-reference and reference node. So voltage of this branch V2, it will be the voltage of the non-reference node. So this will be V2. So this will be plus minus V3, and we have a source here plus minus 5 volt. Okay. So now we will apply KVL to the super node. So first we applied KCL to the super node. Now we will apply KVL to the super node. I am saying a super node is formed by enclosing a voltage source that is connected between the two non-reference nodes and any element that is connected in parallel with it. What is the element that is connected in parallel with this? It is this. So now I will apply this KVL in this node. Apply KVL. Okay, in this node. So what will I get? I will get V3 minus V2 minus 5 equal to 0, or V plus 5 equal to 0, or V3 plus 5 is equal to V2. So if you will see, you have solved this equation. You have not solved, I am telling you, you will solve this equation. You know that we have V1 is equal to 10 volt in this equation. So I can represent this equation, whole equation, in terms of V2 and V3. Okay, so from this equation I got the value of V2 in terms of V3. Now I will substitute this value. Now I have two equations and two unknowns. When you have two equations and two unknowns, you can calculate the unknowns easily. So you can substitute the value of V2 from here in equation this. Okay, if you will do it, you will get the answer. Okay, but I will not do it because this will be a part of your again homework. I will solve another circuit here. So though this circuit looks similar, because I want you to solve 2 or 3 problems related to this this super node. Okay, so let me take a problem for super node. I told you how to solve it. I don't think there will be any problem. V1 is equal to 10. Here V1 is equal to 10. Solve the equation. You will get the equation in terms of V2 and V3. Here you have equations in terms of V2 and V3. Substitute the value of V2 from this equation in this equation and get the values of V2 and V3. It's easy. So next problem. Again, I will take a case of a super node. The problem is like this. This is 14 volt, this is 3 ohm, 2 ohm, 6 ohm, 6 volt, and this resistor is equal to 4 ohm. Okay, so if you will see here a voltage source, 6 volt voltage source, it is connected between these two non-reference nodes. Okay, so this will create a super node. This will create a super node. So simply I will label the, I will say this is my voltage V1, this is my voltage V2, this is my voltage V3. Okay, so here the current that is flowing, it is I1, here the current flowing is I2, here the current flowing is I2, here the current flowing is I3, and here the current flowing is I4. So I will apply KCL at super node. So if you will apply KCL, what are the currents that are approaching this node? This is a complete node. I1 is the current that is approaching the super node, and what are the currents that are leaving the node? I2, I3 and I4. So I1 will be equal to I2 plus I3 plus I4. So I1 is nothing but V1 minus V2 divided by 4. So V1 is nothing but equal to 14, because the voltage source is connected to a non-reference node and a reference node. So the voltage of the non-reference node is set equal to the voltage of the voltage source. So I1 is 14 minus V2 by 4. I1, I2 is V2 by 3. I3 is V3 by 2. I4 is V3 by 6. So if you will solve this equation, what will you get? You will get, if you will solve, you will get 14 V2 plus 16 V3 is equal to 84. Okay. Next, if you will solve, this is KCL. No, this is the no. We have to apply. Second step is apply KVL at super node. Apply KVL at super node. So what is the super node here? This is my super node minus plus. This is my V2. This is my V3, and the element in parallel with this is this. Plus minus V3 plus minus V2, 6 volt. If I will apply KVL at this super node, what will I get? I will get V3 minus V2 minus 6 is equal to 0. Okay, V3 minus V2 minus 6 is equal to 0, or V3 is equal to V2 plus 6. Okay, if I will solve this equation further, so dividing by this whole equation by 2, I will get 7v2 plus 8v3 is equal to 42. Okay, now I know the value of v3 here. I can substitute the value of v3 from here into this equation. So what will I get? So, but you will not draw arrows in this examination. You will say this is equation 1, this is equation number 2. Then you will substitute the value of v3 from equation number 2 to equation number 1. Okay, you will do it that way. So it will be 7v2 plus 8v3 is v2 plus 6 is equal to 42. Solving further, what will I get? 8 plus 7, 15v2 plus 8 6 are 48 is equal to 42. So what will be v2? What will be v2 then? v2 will be equal to minus 6 by 15. Okay, so 3 2s are 3 5s are is equal to minus 2 by 5 is equal to 2 divided by 5, it will be 0.04 4. Okay, so it is v2 is equal to minus 0.4 volt. If I want to convert this into millivolt, it will be v2 is equal to minus 0.4 into 10 raised to power 3 millivolt is equal to minus 400 millivolts. Got it? So you calculated v2. Similarly, you can calculate v3. Okay, similarly you can calculate v3. v3 is nothing but v2 plus 6. v3 is equal to v2 plus 6. Okay, so it is minus 0.4 plus 6 v3. So v3 will be equal to 5.6 volt. v3 equal to 5.6 volt. Okay, so you got the value of v3. Now next, what will you do? So you got v2 v3. Can you calculate if you have v2 v3? Okay, you have v2 v3. Can you calculate i2? i2 is nothing v2 by 3. Can you calculate i3? i3 is nothing but v3 by 2. Can you calculate i4? You can easily calculate. Like if you, I will say calculate i2. i2 is nothing but v2 by 3. Calculate i3. i3 is nothing but v3 by 2. And calculate i4. i4 is again v3 by 6. So you can calculate these three things easily because you know what is v2 and v3. Okay, so if you are given using nodal analysis, you can calculate the node voltage. Once you calculated the node voltage, what you can do, you can know again calculate the branch currents. Okay, got it? So one more problem I will give you guys to solve this problem. Okay, I will not solve it. Okay, so this is a very important problem. I have solved this problem. I think this is an unsolved problem in the book. I have solved this problem, but if I will give you this problem, you people will not learn anything. You will simply learn the methodology, and if such type of question comes in the exam, you will not be able to apply your brain. Okay, so in order to make you guys to apply your brain to understand the problem, I will give you one problem. Okay, so the problem is like that. I have a source here, I have a resistor here. Okay, and I have a voltage source here. I have another voltage source here, which is a dependent voltage source, a resistor here, and again a resistor here, and one resistor is here. So this is plus minus 25 volts. This is 2 ohm. This is 4 ohm. This is 3 ohm. This is 6 ohm. So this is minus. This is plus 5i. Okay. And what is I? I is the current that is flowing in this branch. I. Okay. So you have to calculate the node voltages and branch currents. So calculate node voltages and branch currents. What you have to do, you have to calculate the node voltages and branch currents. Okay, so you have a dependent voltage source here and an independent voltage source here, and you can see this independent voltage source, it is connected between two non-reference nodes, and this dependent voltage source, it is also connected between two non-reference nodes. So what is the problem? How the problem becomes complex, a bit complex here. So I will say this will create a super node. Okay, and this will also create a super node because the voltage sources are connected between two non-reference nodes, both the voltage sources, though this is dependent, but it is still a voltage source. So now I am saying the two voltage sources are connected in cascade, means two voltage sources are connected in cascade, means two voltage sources are connected in series. So it will create a bigger super node. Okay, I am saying two super nodes are connected in, two super nodes are connected in cascade or series, so it will create a bigger super node. So instead, so you have to know, see, you can apply KCL at this node, you can apply KCL at this node. Okay, but while applying KVL, you will have to see how will you apply KVL. Okay, so this is homework to you guys. So with this I am finishing this nodal analysis, and in the next lecture I will start with the mesh analysis. I think 2 lectures were enough for this nodal analysis. So for the next lecture, be prepared for this mesh analysis technique. So solve these problems, solve these numericals, and write these numericals in a notebook. And when the offline classes will resume, I will definitely check these problems, whether you have solved these problems or not. Thank you very much.